Welcome everyone. This is so great to see everyone. Hello and welcome to Water Crises on the Blue Planet. What water's past tells us about humanity's future, which is brought to you by the History Department and the College of Arts and Sciences at The Ohio State University and the magazine Origins, Current Events and Historical Perspective. It's really a pleasure to be with everyone today. My name is Bart Elmore. I'm an associate professor of environmental history and a core faculty member of the Sustainability Institute here at Ohio State. And I'll be your host and moderator today as we talk about these important issues surrounding water. Welcome to everyone, and thank you so much for joining. Today, we are really privileged to welcome Dr. Nicholas Breyfogle, who will explore the historical roots of today's global water crises and the ways in which humanity's relationship with water has changed over time. Across human history and throughout this very diverse planet, water has defined every aspect of human life, from the molecular, biological, and ecological to the cultural, religious, economic, and political. Water stands at the foundation of most of what we do as humans. At the same time, water resources, the need for clean and accessible water supplies for drinking, agriculture, and power production will likely represent one of the most complicated dilemmas of the 21st century. So we're going to dive into this big and comprehensive topic, but let's take a moment to get to know our wonderful speaker for the day. Nick Breyfogle is an associate professor of history and the director of the Goldberg Center for Excellence in Teaching at Ohio State. He is a specialist in the history of Russia, the Soviet Union, and in global environmental and water history as well. He is the author, editor of multiple books, including Eurasian Environments, Readings in Water History, and Hydraulic Societies, which are all relevant to today's discussion. He's currently completing the books Baikal, The Great Lake and Its People, and this is pretty profound here, Water, A Human History. This is going to be a big opus piece. Since 2007, Breyfogle has worked as co-editor of the online magazine podcast video channel Origins, Current Events and Historical Perspective, and most recently, of Picturing Black History. And I should note also that he has been a leading figure in developing the environmental history program here at Ohio State. So with that introduction, let me mention the plan for today. Professor Breyfogle will begin with a presentation on the historical roots of today's water difficulties. Then he will take your questions and we will open things up for discussion. If you're interested in asking a question, please write it in the Q&A function at the bottom of your screen on Zoom. And then I'll read your questions to Nick as we move along. We'll do our best to answer as many questions as we can. We've received several questions in advance, so bear with us as we try and get to as many of your comments and questions as we can. Also, we'd like to acknowledge that the land the Ohio State University occupies is the ancestral and contemporary territory of the Shawnee, Potawatomi, Delaware, Miami, Peoria, Seneca, the Wyandot, the Ojibwe, and Cherokee peoples. Specifically, the university resides on land ceded in the 1795 Treaty of Greenville and the forced removal of tribes through the Indian Removal Act of 1830. We want to honor the resiliency of these tribal nations and recognize the historical context that have and continue to affect the indigenous peoples of the land. Now, let me pass you over to Professor Nick Breyfogle, who will take us on an exploration of water crises on the blue planet, what water's past tells us about humanity's future. Over to you, Professor Breyfogle.
Thank you so much for that introduction, and welcome everyone. I'm delighted that you've all joined us here today. Hopefully you can all sort of see the screen that I got up. First, a very happy World Water Day to everyone. March 22nd is the day we remember just how important water is to us. And so I wanted to talk a little bit today about the kind of human relationship with water over time and what it teaches us about the current dilemmas that we're often facing when it comes to water. I want to begin by asking, sort of raising a question that I actually ask of my students a fair amount, which is, what is your relationship to water? And it's an amazing thing because this is a question that is often very hard for students to find an answer to, in the sense that for most people, particularly in the United States, they don't think a lot about water around them. Water comes out of a tap. It's there whenever they need it. When I ask them, what's your relationship to water? They say, well, I drink my 8 glasses a day. I use it for bathing. I use it for swimming. Maybe I go wakeboarding. So drinking, bathing, leisure types of activities are usually the list that I get. And it's an interesting thing because it reflects the ways in which water has become, for many of us, something that we don't even think about. It's just part of our daily lives. It's part of the background of our existence, and we don't think a lot about it. And yet, water is everything in human life. I mean, without the molecule H2O, life as we understand it simply wouldn't exist. And water is has been and is at the core of just about everything that we do as people. In irrigation and agriculture, and waste and sanitation, in drinking and disease, in floods and droughts, in religious beliefs and practices, in fishing and aquaculture, and travel and discovery, scientific study, and water pollution and conservation, dam building, boundaries and borders, wars and diplomacy. I mean, the list can go on. I mean, I raced through that, but almost every aspect of our existence is one that is defined by water. And so it's an interesting moment when you ask people, well, so what's your relationship to water? And they can't quite think of it, even though water is so crucial to everything that we do. So there's a strange way today in which, at least, for example, in the United States and other very well-off countries, our relationship to water is something that we don't think about and is in some ways in the background, just part of our daily existence. At the same time, we live in a moment where, at least in my news feed, we now all get our curated news feeds by some kind of algorithm and this sort of thing. But at least in my news feed, there's a lot of information about news where it seems like our relationship to water as humans has fallen out of balance in one form or other. That we read one day about terrible floods, which are taking down societies, and in other days we read about drought, where we have too much water some places, some days we have too little water in other places and other days, and we hear a great deal about water pollution, and whether it's chemicals coming into the water, harmful algal blooms, coming from nutrients from farming in particular, plastic waste, and here you can see it in its bottle form, but more and more we see water pollution in the form of sort of nanoparticles, things we can't see that are in our water. And then impact on aquatic life, such as the bleaching of coral and this sort of thing, so that we have this sort of strange situation where on the one hand, we almost don't notice our relationship with water. And on the other hand, we have all of these examples of a world a little bit out of balance when it comes to the human relationship with water that are around us today. And what I want to do with all of you today is to kind of think about the sort of question of, well, how did we get here? How do we get to this point where water is both an afterthought and something at the very forefront of a series of problems that we're confronting? And what, if anything, can we learn from the past about the human relationship to water as we're thinking about how to resolve or to confront the kinds of issues that we face at the moment? And the question of, well, what can we learn from the past? Well, the answer is a lot. And what I mean by that is that the past is this remarkable data set of information about the human relationship to water. humans and water have been together from the very beginning. So from the very first moment of our species, the question of the human-water relationship has been a central part of what it meant to be human. So in that sense, for the last 200, well, maybe even 300,000 years, depending on where you date the beginning of our species, the human-water relationship has been at the very core of everything we've done. And humans have had a lot of opportunities to think about how to set up that relationship and how to ensure that they have the water that they need. At the same time, the past is so often talking to us, and I don't mean sort of indirectly, but often really quite directly. Up on your screen, you can see what's called a hunger stone. This is a stone that's actually at the bottom on the bed of the Elbe River in Europe. In 2018, there was a very dry patch, and this stone then appeared from under the water as basically the water disappeared in the river. And one of the things you find on this stone is a whole series of carvings and engravings from other times in human history where the water has dropped to expose this big rock. These stones go back, the engravings go back into the 15th century, and they tell of years where water was insufficient. And there's one really remarkable kind of carving in it where it's written in, if you see me, weep. And is a remarkable kind of thing to kind of see that, here's a moment where the people from that time, there wasn't enough water, they couldn't grow the crops they needed to grow. The result was massive famine and death. And you see this effort on the part of our forebears, right, to reach out across generations, to warn us, to warn people who are not even born yet of the dire consequences of what happens when the water disappeared. And you can see a kind of range of emotions that they have here: sadness, fear, anger, resignation, and to the point of bringing tears to their eyes. And it's a reminder of this kind of shared human experience that we have over the whole question of water and across time, and the way that humans speak to us from the past. It's also worth noting that this isn't something that just happened a long time ago, but in fact, humans today are also speaking to the future. This image that you see up here is from August 2019. It's a group in Iceland, including the Prime Minister Katrin Jakobsdottir, who held a funeral ceremony for the Ökjökull Glacier, which they shortened to OK. And they had a funeral ceremony for it and laid a plaque to memorialize the loss of this glacier. They did this because in 2014, geologists had stripped the glacier of its status as a glacier because basically it had entirely disappeared by that point. And the plaque is this letter to the future, which reads, OK is the first Icelandic glacier to lose its status as a glacier. In the next 200 years, all our glaciers are expected to follow the same path. This monument is to acknowledge that we know what is happening and what needs to be done. Only you will know if we did it. And so if our first stone was from the past to us, here we are as humans today speaking out to the future and marking important moments in our relationship with water, so that the communications that we have across time about the human water question are very real and ongoing. And it's just such a reminder of the importance of water in all its forms to all of us. So let's talk a little bit about what we can learn from the past. And the first thing I just want to highlight before we jump in is just to note the actual hydrological structures and locations of water on our planet. I'm often asked, well, how on earth on the blue planet, which has so much water on it, could we ever be in a place where we have too little water or not enough, or water that we can't use. I mean, there's just so much water around us, right? And part of the answer to the question of, well, how can you have a water crisis on a blue planet is seen in this chart here, that of all the water on the planet, only 3% of it is fresh water, right? The other 97% is salt water of some form, so not very good for human use. Of that 3%, then most of that, 99% of that 3%, is hard for us to access. Either it is deep underground in aquifers, or it is frozen solid in ice caps or glaciers, and so difficult. I mean, you can go chip off ice and melt it down to be used, but it's certainly not coming out of your tap in that way. So of the 3% of all the water, only 1% of it is actually relatively readily accessible to humans. And of that 1% of 3%, you see this kind of a breakup of things, where about 38% is in the soil, again, difficult for us to access, and about 52% of the 1%, of the 3%, in lakes for us to use. So that while we are a blue planet with a lot of water on it, the accessibility and the usability of, or at least from an ease of use, an ease of accessibility perspective, it's really hard for us as humans to access this kind of essential resource. That said, there's still lots of water on this planet. I mean, this 1% of the 3% that is down here, still a lot of water, more water than we needed if it all ended up in the same place at the same time. Plus, there's water underground and water in the ice caps. So it's not a sort of lack of water per se, as we'll see, that is the biggest problem we face. It's also just worth noting that water is a kind of magical kind of molecule, in the sense that it has all sorts of characteristics that are important for us. It's the only molecule on the planet that exists naturally in all three states: gas, liquid, and solid, and that's quite remarkable. It's also really interesting because its solid form is lighter than and less dense than its liquid form, which is why ice forms in the top of a lake. Super important for any species who wanted to live in a lake that it's at the top rather than at the bottom. Worth noting that water is both cohesive, that it sticks well to itself, and adhesive, that it bonds with other molecules as well, which is why water is very rarely just simply water. It's not just H2O. It's often connected with other things. And it's also worth highlighting that water is pretty heavy, about 8.34 pounds per gallon. So it's not easy to move. And if humans want to lug it with them, it's a problem. So some of the basics of our very cool magical molecule that is water. Let's talk a little bit about the history. And I want to highlight three basic stages of the human relationship to water that give us a sort of sense of the changes over time of our relationship to water, and the ways in which, how we got to the world in which we live in today. It's worth noting that for most of human history, the first 200,000, 250,000 years, humans lived as hunter-gatherers who migrated around following water wherever they needed to find it. So if water disappeared in one place, they would move somewhere else. We don't really have any evidence from this time of humans putting water in jars or moving water in any sort of a way. As far as we can tell, basically, humans moved to wherever the water was rather than moving the water themselves. So we have this kind of migratory thing. And if you had a moment where there was too little or too much water, you simply moved somewhere else where the amount of water was what you needed it to be. It's also the case that all of the other animals that, as humans, you might want to hunt and eat, they tended to move with the water as well, so that as you move from one spot of water to the next, you would move with the animals that you might want to hunt. Many of the plants you might want to eat were growing in that water, so that food and water and humans kind of connected together in this way. We know that humans have been fishing for quite some time. We have fish hooks, here from 23,000 years ago from Japan, so that humans were getting fish out of the water at that point. It's important to note that through this whole period, one of the things that has allowed humans to survive and to thrive is, in fact, the ways in which water makes up most of our body, and the ways in which we have a self-cooling system through sweat and the kind of evaporation of water on our bodies to cool ourselves. Humans are quite remarkable. There are lots of species that are faster than us, stronger than us, but there are very few species that can match us in terms of persistence and our ability to keep going, because we're able to cool ourselves. Most other species don't have the same kind of self-cooling system, so they can sprint for a while, but then they overheat and have to cool down. Humans can keep going, keep going, keep going. So our ability to hunt is one that, our ability to hunt has been extraordinary because of our ability to cool our own bodies. And to keep going, keep going. So our prey might run away from us, but as long as we can track it, we can keep going even after the prey has to stop. And so this was human life for most of human history. Migration, following water, always living close to water, moving when they couldn't, and using this remarkable sweat system that we have in order to be able to get the food that they wanted. Are needed. We see a profound change in the human relationship to water about 12,000 years ago. And this is the beginning of the world in which we live in today. There'll be a third stage I'll talk about beginning in about 1750, so very recently. But so most of human history is about migration and moving with water. Then we see a big change about 12,000 years ago, where we start to see a shift towards humans living in kind of permanent settlements and engaging in settled agriculture, where humans stay in one spot and then grow the food they need in that spot and then live in that way. So rather than going out to hunt or to gather solely for their food, they're now going to grow their own food locally. And this is a huge transformation in human life. And in many respects, it's this moment, 12,000, that begins about 12,000 years ago. It takes a while to come into place. That really sets out the kinds of dilemmas that we're facing today. And what I mean by this is that the move to settled agriculture creates a kind of disjuncture between humans and water, in the sense that water is always in motion, on the ground, underground, in the air. It's always, for the most part, with very few exceptions, moving somewhere. Humans have now set themselves up, beginning about 12,000 years ago, in a settled kind of spot. And so suddenly water's moving, but humans aren't moving anymore. And so to be able to access the water that they need, humans have to figure out other types of solutions. And this then raises the kind of four big issues that humans need, because humans need a specific amount of water, of a specific quality, so water you can use to grow crops or to drink or this sort of thing, at a specific place and at a specific time. And struggling to bring those four things together, quantity, quality, location, and timing, has been the defining characteristics of human history from this point forward. And we still live in that. We're still working to ensure quantity, quality, location, and timing. Now, this may set up a kind of disjuncture for us and a set of problems that we need to resolve, but it also has brought into existence the kind of civilizations that we now understand, and the kind of beginnings of the kind of world as we understand it today. So based upon this kind of new type of settled agriculture, we start to see the development of what are often known as the Cradle Civilizations. These are different kinds of communities that developed around usually a large flooding river. They were irrigation based for agriculture, producing usually wheat, barley, and millet. And so we have, for example, in Egypt around the Nile, Mesopotamia around the Tigris Euphrates, the kind of South Asia around the Indus and Ganges, and the Yellow River and the Yangtze, the development of kind of Chinese civilization. These are societies that start to take on characteristics as we understand them today. These societies have to develop very complex social and political relations to make sure that they can provide the water that they need, whether it's building reservoirs, releasing water into irrigation systems when they need it, and organizing labor to do all of that kind of work. We start to see the beginnings of what we might call urban societies, and the development of the first examples of writing, like the Sumerian cuneiform here, artwork, and such as this statue from Egypt, the beginnings of the first law codes, now written down because they had the writing to do, and such as Hammurabi's first law code from the Babylonian period of Mesopotamia, which has lots of lines in it about water, because the laws were thinking a lot about water at that time. Taxation systems, all these sorts of things that that we associate with modern society today. We also see the development of the first types of kind of water provision and sanitation structures that are now such a core part of urban living in the world, that at least in the United States, to the point that we've actually forgotten that they almost even exist because they're buried underground and we don't really see them. We flush and forget, as they say. But the first civilization that we can see who really developed these kinds of structures were the Harappan Civilization on the Indus Valley, and now 4,000 to 5,000 years ago, they developed a kind of well structure system. This is the first indications we have of, or the first archaeological remains, earliest archaeological remains that we have of this kind of circular well structure. And we start to see this is an old shower system here on the kind of top left. We can see sanitation troughs to kind of move human waste away from people's homes. So we have water supply, we have cleaning areas, we have sanitation systems that are getting put into place here. And they have what's known as the Great Bath. We don't know what this is, what this was used for, but it was clearly for holding water. And then something happened here with that water, we don't know. The Harappan Civilization flourished for a long time and then disappeared, was only discovered several centuries later. They have writings, but we have yet to crack the code of them, so we're not quite sure what these are all about. But we start to see the beginnings of these kinds of structures. We also see over sort of the several thousand years between 12,000 and 1750, 12,000 BCE, 12,000 years ago and 1750, the development of a whole series of new types of machines which use the power of water in order to do all sorts of jobs for us. So particularly water wheels that could be used to, as in this case, to power a blast furnace to be able to produce higher quality metal, to be able to produce higher temperatures, to produce higher quality iron, or systems like this, water wheels to crush stones for various purposes. We see the development of incredible infrastructure to be able to move water from one place to another. This is one of the aqueducts of the Roman Empire, the Pont du Gard in Avignon in southern France. An amazing engineering to be able to move water solely through gravity from one place to another. Not too steep, because if it's too steep, it erodes. Not too flat, so that the water keeps moving. Remarkable kind of infrastructure that gets built around water this way to bring water in when people found that, for example, wells weren't enough to bring water for a city, now to bring it in from the outside. Oops, sorry. We also see increasing efforts to try to what, as the Dutch call, land winning. That is to separate out water from land in wetland areas, to create land where there had been kind of marsh before for agricultural purposes and for living purposes. If anybody looked at the lands where Holland is at the moment, they would hardly think to themselves that this was an auspicious place to start building a society, in the sense that about 25% of what's now the Netherlands is below sea level. Without protection, about 65% would flood regularly. So to build a society in this area required then building an elaborate protective dike and dam structures to keep the water out, and to think about new ways to try to move water from one area to another. If you wanted to dry land, how to move the water away. For the Dutch, they did this particularly through wind power, so that to be able to lift water against the force of gravity from lower to higher, they use wind power to make that happen, and create just the most remarkable civilization in the process. Now, we start to see across the world the ways in which these kinds of civilizations that build up over the course of these thousands of years, some of them thrive for hundreds of years and then have some kind of disappearance or collapse. Just to give one example of this, this kind of process, one can look at the kind of southwest of what's now the United States, and look at territories of the people, the Hohokam, or the ancestral Pueblo, who existed kind of around the four corners of sort of Utah, Colorado, Arizona, and New Mexico, and then also in Arizona itself. These were two highly flourishing, kind of settled societies. The Hohokam in particular, irrigation-based, incredibly elaborate engineering in that regard to bring water in. They built kind of remarkable dwellings and towns and societies. This one, for example, Mesa Verde, with sort of underneath this rock outcropping as kind of protection, really remarkable, and existed for several hundred years and then suddenly stopped. There's a sudden moment where the people in this area disappear, and where you can see towards the end of their existence there that there was a fair amount of violence and fighting. As best we can tell from looking at climate records, the disappearance of these societies almost always tends to coincide with moments of dryness and extended kind of drought. And so it's a reminder that water helps to build these kinds of civilizations, and then when the water stops or drops to a certain level, we see a kind of collapse of these civilizations, and it's pretty rapid and often quite violent. And it's perhaps not surprising. I don't know if any of you have seen this kind of map of the of rainfall in the United States. The United States today is in many respects a two-part country. There's the East, where we see more, on average, more than 20 inches of rain a year coming down, and where one can conduct agriculture just based upon rainfall, most years. And then there's the West, where you have less than 20 inches of rainfall on average a year, where it's really hard to have consistent agriculture based upon rainfall. And so if you're going to have agriculture there, it has to be irrigation based. These societies I've just talked about are in this kind of zone where it's a pretty dry place to be. And so perhaps not surprising that they were able to kind of engineer a long kind of stretch for themselves. And then when water just simply became became insufficient, then the society can no longer hold together. Now, the third stage in kind of the human history with water is a really recent one. So we've had most of human history hunter-gatherer. We then have about 12,000 years which is this kind of settled agriculture period, the rise of kind of these historic civilizations, and sometimes the fall of these civilizations as well, the development of new types of technologies, urban development, laws, all of this kind of thing. And then beginning at about 1750, we see humans coming into our current stage, which is a relatively new one and a really quite remarkable one. In the sense that it's at this time where we start to unleash not just the power of water as it flows, say through water wheels, but through the power of steam. By initially merging the energy of fossil fuels and the burning of coal, which could then turn water into steam, and then utilizing the transition of water from steam to water, from gas to liquid and back and forth, allowed us to produce a whole series of new types of machines that could do all sorts of work for us. It's the beginning of the industrial transformation that we're still living in. It also begins a time period where humans began to really think of themselves as able to conquer water, control water, solve the water problems, that technology and kind of human ingenuity would fix everything. And this idea, which didn't exist for other human generations, really starts to take off after 1750. One of the things amazing about this time is just how rapid the population growth was, that coincides with this new use of water as part of the industrial change. You can sort of see this is the kind of beginnings of settled agriculture, about 4 million people on the planet in total. And then we go from a horizontal growth line to a vertical growth line really quickly. So, we live in a very different type of world now as a result of this new kind of use of water that we see at this point. Just kind of quickly to kind of characterize some of the things that really are different about this new period in which we live. The first is our ability to grow a great deal more food than we ever have. Part of that has to do with technological ability to move water through pipes or other kinds of irrigation systems, the development of new types of technologies for watering crops. But a lot of it also has to do with accessing new water sources, and particularly water under the ground in aquifers. And so the ability to pump using steam technology initially then has allowed us to bring water out from this previously inaccessible areas, like the Great Artesian Basin in Australia, underneath Saudi Arabia, the Ogallala Aquifer on the Great Plains of the United States, or the aquifers underneath California. So we've been able to see a rapid increase in the amount of agriculture and food we're able to produce. We fundamentally transformed rivers. We have redesigned them. You can sort of see, this is an example of the Rhine River, where natural rivers bend and flow and twist and turn and change direction and move in all sorts of different directions, have all sorts of oxbows and tributaries, and are a mess, honestly. And over the course of the 19th and 20th century, humans across the planet have generally re-engineered these rivers much more to look like canals. And you can sort of see the difference in these three pictures here. Very few of us actually have ever seen a river in its natural state anymore. So great has been the transformation of rivers in the process. And you can see this painting versus this photograph here. This canal here with very smooth edges, good for transportation, and as opposed to this one with wetlands everywhere, meandering, and this sort of thing. So we fundamentally redesigned all of our rivers. We have impounded vast amounts of water behind dams, both hydroelectric and not. And here's the Hoover Dam, and one of the first that began this process. You can see from this chart here the ways in which we have massive outburst of dam construction after World War II, to the point that not only have we redesigned rivers to be basically like canals, but we have now impounded most of the world's water into these massive reservoirs that then provide water for irrigation, for leisure activities, for hydroelectricity, and for a variety of other types of purposes. So we have redesigned the whole water system on our planet, most of which has happened after the Second World War, so very recently. We've also, and this is perhaps the most remarkable thing, is made it possible in many parts of the world for water to be safe to drink. Historically, humans tended to stay away from drinking water because water tended to be a home for disease, and humans drank other sorts of things, fermented, boiled, or otherwise adulterated forms of water, of liquid. But beginning in the mid part of the 19th century, we see the beginnings of a process of installing new sanitation systems, efforts to clean water, so that you can drink water out of the tap, or at least I can in my house. And it's a remarkable transformation, and one that has divided the world between those who can do that, who have clean, safe water, from those who haven't. And the last thing I would just add about this, the world in which we live in today, is that as part of our industrial transformation, we have invented new sorts of kind of pollutants. Water used to be dangerous because it had disease in it. Now water becomes something that we might be worried about drinking because it has other forms of pollutants, toxins, chemicals, other sorts of things, generally things that humans have created themselves as part of industrial change, that is now making their way into our water, that affects then our ability to use the water to drink, for agriculture, for all sorts of different types of purposes. So that as part of our recent industrial era of water use, we are in an interesting moment where we've solved a lot of problems through our industrial use and new types of technologies. At the same time, we've also created new water problems for ourselves, and these are ones that we're going to have to face moving forward. So that is an overview of the kind of reality in which we reality in which we live today, and the ways in which we've come over time through these three stages of kind of the human relationship with water. So with that, let me pass over for questions.
Fabulous, Nick. What a great presentation. I'm going to jump right in. We've got some questions from before we came on this webinar. The first was from someone who was interested in chemicals. It's a great segue to what you just said, because you were talking about industrial pollution. Someone who's really worried about, how do I protect myself from all these chemicals that are out in the environment now that are being pushed by big multinational firms, specifically pesticides and herbicides being used on property around where this individual lives. And, asking really the question is, how do we fight back? What does history teach us about being able to ensure that these pesticides and chemicals don't end up in our groundwater, that go into our wells or, in our municipal water supply?
Well, I think that the answer to that question is, will vary depending on where you are in the world. In our sort of our democracy, with our kind of with our sort of economy, part of the answer to that question is please, one has to make choices about what one purchases, because we know that, ultimately, whatever we put into our garbage, that goes into landfill, whatever we stick into the ground goes into the water table. So much of what we consume is going to come back to us through water. So it starts with us. We need to consume fewer of the things that are going to be dangerous to our health, and at the same time, we also need to be really active politically. And what I mean by that is, talking to the people that we elect to say that this is a real priority for us. Part of the reason I highlight the ways in which we forget about water is that we have forgotten about it. We don't realize how important it is for us. We're not as active as we probably should be in requiring that the water we get is going to be healthy. And it's expensive to maintain the systems that we have. That's for sure. The other thing I would just highlight is I think most people who own a house or whatever, we often get sent a report about the status of our water, what's being cleaned, what are the chemicals that are being taken out, all these sorts of things. Most people don't read them, and you should go see what is your municipal water system doing to protect in that way, and then to demand, as voters and taxpayers, some kind of change. I mean, these are, as with everything, it all begins with us in terms of making those kinds of changes.
We got a question about booze, always fun. A question about beer and alcohol. And the question is basically, is it true that back in the day, so to speak, alcohol was the safest thing to drink? And when did that change? When did people's, perception that drinking alcohol was a good way to stay safe from all the germs and stuff and unclean water? When did that kind of idea take hold, and when did it change?
Well, and the amazing thing, because I think I assume that most of us are sort of like me, where I drink a lot of water. I follow the guidelines that I should be hydrating all the time, and it seems pretty natural, right, that we would want this. The short answer is that it really begins about 150 years ago, and where we start to really see with the bacteriological revolution, where we start to understand what caused disease, that there were these things, bacteria or viruses, invisible to the human eye, but that were causing disease for us, and that we could, through a series of filtering systems or other types of cleaning processes, we could take those out and suddenly make the water much safer to drink than it had been before. But it's really only in the middle part of the 19th century, the latter part of the 19th century, that we start to see these changes really coming in, and a shift in terms of thinking about whether water is safe to drink or not. Because for most of human history, humans saw water as dangerous, ultimately. And so, in Roman society, for example, just going back, a couple thousand years, water was drunk by people sort of lower on the social hierarchy. So slaves drank water, children drank water, women sometimes drank water, but people who were better off, people who were citizens, they would take their liquids in through things like wine or other types of liquid that had been transformed somehow, heated, fermented, or otherwise, or sometimes cooled too, that they would approach it in that way. So it's a very recent type of occurrence, and it's unusual for humans to have this kind of sense of water as being really, welcoming, and that we should be, guzzling it rather than be scared of it.
That's great. I'm going to send two questions your way. One is, it seems very small, but maybe you can answer it. Mary Barbara Alexander asked, what are the Japanese fish hooks made out of that you mentioned? And then Neil Humphrey, graduate student, shout out here in our environmental history program, asks a broad question. What are some of the most prominent ecological issues with transforming meandering rivers into clear, straight, navigable waterways? I think that's a great question, Neil.
So fish hooks, my apologies, I don't know for sure. Most fish hooks historically were made either from some kind of, usually from fish bone of some sort, or sea mammal kind of bone, and occasionally from wood or other kinds of products from the land, but often taking the bones of other animals. I'm not sure about those Japanese ones in particular, so I can't be 100% sure, but usually from those other sources historically. And to answer the question about transforming rivers, the ecological impacts are significant. So a meandering river, and one in which changes course and direction, in which there's kind of shallows and deep parts, and is kind of messy, are often very rich ecosystems, so that you're going to have a wide range of different types of species that can live, because you've got some parts of the river that are moving fast, some parts of the river that are moving quite slowly. You have shallow parts, you have deep parts, you have different kinds of little micro ecosystems in the different parts of the river. So the result of which is that when you straighten a river, biodiversity decreases quite rapidly. There's a whole set of species that simply can't exist anymore in the areas that have been transformed. So remarkable shrink in biodiversity and a shift in terms of the species that can or cannot live in the river. So that there's a species of fish in the Rhine, and I forget the number off the top of my head, but it's there's a large number of species of fish in the river that were in the Rhine that don't exist anymore. They just simply can't handle, they can't spawn or they can't live in the new kind of system that's there. So that it's a fundamental transformation of the ecosystem. The other thing I would just highlight is that when you straighten rivers, you have an impact kind of on the whole geological structure of the river itself. So that when you turn rivers that meander into straight lines and with defined shores, you often increase the velocity so that rather than meandering, it's going straight through. The faster the water moves, the more likely it is to erode the bottom. It picks up all sorts of sediment with it. It then moves it down the river. So in the Rhine case, for example, you now have sediment that was at the very top of the Rhine, in Germany or Switzerland or this sort of thing, that is now coming out at the very bottom of the Rhine into the Netherlands, clogging up their river system and affecting those areas as well. So that you have changes in species life, but also changes in the movement of sediment and soil.
That's great. And I'd mentioned too that in the United States, there are over 75,000 dams over 3 feet tall in the United States. Essentially, if you looked at a map of the country, you have congestive heart failure in terms of blocking the flow of nutrients to waterways further downstream. So a big issue there. I'm going to put, again, 2 questions your way because they're kind of connected. There's a person who asks, is it bad for the earth to pump water from aquifers? That is, does it cause problems for the planet, such as earthquakes? I think that's a great question. And kind of related, is it possible for modern societies to collapse under water stress or scarcity the way many ancient societies have? Are we still vulnerable, or are we more resilient now to mega droughts and because of mismanagement?
So I'll do the second question first. I mean, in terms of could modern societies collapse? Absolutely. I mean, at the end of the day, we are a species that requires water to exist. And depending on how we've set up our lives and, depending on what we grow for our food and how we use water, for economic activities and for other and domestic activities or whatever, the amount of water we need as a society varies from place to place. And it's worth noting that it's still the case that 70+% of the water that we use is water for food, for agriculture. So that, most of the time when we think about water, we think about the water that's coming out of our tap to drink or for showering or whatever. But our real water usage is always in food. And that's one of the real perils to us that if there's no water, then there's no food, and that's in some ways the long-term type of danger. Now, so that in the sense that it is still possible, absolutely, for societies to collapse in this way. And again, because we have to have these 4 things. We need a certain amount of water for the types of economic and kind of domestic activities. It has to be of a certain quality. I mean, if it shows up as salt water or with poisons in it or whatever, we can't use it. It has to come at a specific time. Water's no good for crops if it comes at the wrong time. And it has to come in a specific location. If my crops are here, it doesn't do me any good for it to rain over there. So that fundamental problem remains for us. We have, though, as a species, done amazing things to kind of to be able to mitigate some of those problems. We'll never be free from this disjuncture. We'll never be free from the fact that we need water to survive. But our ability to store water, for example, our ability to move water from one place to another, and our ability to drill water up from under the ground has made it possible for us to smooth out some of the rough edges of that whole process. So we're able to live more and more without having to think about water because of these kinds of technological structures. The caveat to that, of course, is that the more things work well in a society, the more we see the population rising, the more we see populations rising, and populations need food. So the more populations rise, the more food we need. That our ability through technology to be able to bring water to where we need it at the right quality and the right time, and all these sorts of things, is now starting to be balanced by the fact that our population is rising so quickly and greatly that if we came to a point where we ran out of water or it became too little to be able to produce our food, then we would have a lot of people affected. For food, it does help that we can move food in a way that people 5,000 years ago, even 300 years ago, couldn't. We have transportation, global kind of networks in that way to make these things happen. So very much still possible, and we should be always on the concerned about that. But there are these mitigating factors that we see in action. I was asking about kind of pumping groundwater out. The biggest issue in that regard is a human one. There are geological, and I'll talk about that in just a sec, but the human one is this, that we have big chunks of our agricultural economy in the United States and globally that are based upon aquifer water, that are based upon pumping out water from the ground. This water that is in the ground generally replenishes itself very slowly over the course of thousands, if not tens of thousands of years. And so we're taking out much more water than we'll ever go back in. So that the aquifers underground are finite resources. And in that regard, we're only going to be able to support agriculture based upon aquifer water for so long. At some point, it runs out. At the same time, sometimes the water that gets pulled up from the aquifers is not healthy. There was a huge arsenic poisoning kind of epidemic in Asia. The UN had put together a process of drilling wells to bring water up under the ground. And it turned out, and they didn't bother to test the water when it got up there. This water had high concentrations of arsenic. They didn't realize until too late. There's an entire generation of people who've been poisoned by this arsenic. And so that, the water we bring up isn't necessarily pristine. It is in some cases, in other cases not. So aquifer water is finite. We can only use it for so long. And of course, when it stops, all of that agricultural infrastructure and economy is going to stop with it. There's nothing to replace that, plus the kind of health issue. In terms of kind of geological kinds of questions, it is possible, as you take the water out, the water supports land in certain places. So as you take the water out, that affects the structural integrity of many of these kinds of caverns and caves. So for example, in California at the moment, in the Central Valley, the land is subsiding. It's going down, and substantially. You can see it happening. And because they're pumping up vast amounts of water from under the ground. The drought over the last decade plus out in California has led to a tremendous amount of pumping from underground. The result is the land is subsiding. And we see that in a variety of places around the world. So you kind of see the subsidence of land, and because nothing's holding it up anymore, and occasionally, right, that can lead to instability on the ground. Now, earthquake may be too strong a word, but you can have shaking as a result as land subsides and kind of collapses in various forms.
We're at time, but I hope it's okay to address these last two questions here, because I think they really matter, Nick. And if we lose some folks, that's okay. We'll record this. But one question is one that's on everyone's mind: is desalination the way out, especially given that renewable energy is making this more cost affordable? Or are we going to face, instead of a water scarcity issue, an energy scarcity issue of being able to power these desal plants? Can you muse on desal as the solution? And then I think this other question is really important too. Like, as a paddler, cubic feet per second is another thing I'd throw in. The question from Forrest is, there's all these different types of ways we measure water, but none of them really make sense to any of us. Billions of liter feet, meters of water equivalent, like gigatons. What does that mean? So is part of this a translation issue of dealing with the scale of all of this? If you could muse on those two things, and then we'll conclude.
Okay. So desalination or desalinization, this is an interesting question. I get asked this a great deal. Obviously we have the technology at the moment to be able to take to separate salt from water, and the problem with it is that as the technology currently exists, it is tremendously expensive and tremendously energy intensive. So that yes, we can do it. But the cost is so great that it doesn't make sense particularly for agriculture. If you're growing grain, for bread, or you're growing corn for livestock feed, if you're using desalinated water, your feed's going to be just simply so expensive that it's even hard to imagine at this point, given the way that the technology is at this stage. So that it can provide a small amount of additional assistance in specific places, particularly for drinking water. And that's where it can be used and where it is being used. I mean, for drinking water, for cleaning, for domestic types of activities, it's super expensive still, and very energy intensive, but it can be used in that regard. So at this point, it's not a solution to these kinds of questions, because we can't produce food with it yet in a way that makes any sense whatsoever. The other problem, of course, with desalination is that you have leftover byproducts. I mean, you are extracting salts and from the water. Where does all that brine go? You can only extract so much. You've got a waste product that you then have to deal with, and salt is, salt kills the land. You can't make the oceans too much saltier than they are, otherwise it starts to affect the species that are there. So you have the byproduct issue that we have with so many things that are also going to be there. So a massive scale kind of desalinization process, I don't see happening anytime soon, just because of these two really big problems and issues with it. So then just a question of scale. I mean, I do think that it's at least in the United States, I mean, I think that part of the issue that we have is, I mean, it is a scale issue in the sense that we live on this blue planet with all of this incredible amount of water, whether it's salt water or fresh water. We have frozen water in the forms of glaciers all over the place. There's so much kind of just seemingly this abundance. I mean, you look at the picture behind me. Doesn't look like we have a problem when you look at Lake Tahoe like that. It looks, pretty magical, right? And yet it's hard for us to kind of come to terms with the issues that actually it's not about all of it. It's about the amount that we can use, and it's about having water. Again, it's the four things: quantity, quality, location, and timing. This beautiful water in Lake Tahoe does very little for me in Ohio. It might be able to grow some crops that you could move over. But the sort of distance is just so great, so that we can have lots of water, but it's not always in the right place, of the right quality, and in the right quantity, or the right timing for what we need. I also think that part of it is our inability to kind of really conceive of having a lot, but also having very little at the same time. And that graph that I showed of all the water coming down to that sort of 50% of a 1% of a 3%, tiny amount that we can actually use. The second problem is the one that goes to my question that I started with: what's your relationship to water? In the sense that, at least in the United States, we've gotten to the point where we take water for granted. We don't think about it. So it's not even, it's just there. So that we haven't paid attention to how important water is in our lives. We haven't prioritized it. locally. We don't give thanks when we turn on the tap and water comes out, and we should, because for most humans that hasn't happened and didn't happen historically. And we have this just miraculous kind of thing that we can open a tap and that it's not going to kill us, the stuff that comes out. So we've forgotten how important it is to us as a species in the process, so that coming to terms with what's going on requires us to go back to our roots as humans and as a species, to realize how important this is, to prioritize water questions in our politics and our economics and everything that we do, and to be aware every day of the importance of water in our lives.
Well, here. Thank you so much, Nick. And thank you all very much for joining us today and for your excellent questions. This was really a delight for me, just moderating this. I'm grateful to Nick Breyfogle for sharing his expertise and passion on water history. This has just been great. Please join me in giving me a virtual round of applause. And we would also like to thank the College of Arts and Sciences, especially Alex Stacklane, the Department of History, the Goldberg Center, and Origins Current Events and Historical Perspective for their support. Stay safe and healthy, drink clean water out there, and see you next time. Goodbye.
Thank you.